Welcome back. We're on Giancoli Ch2 Problem number 6. According to the rule of thumb, every 5 seconds between a lightning flash and the following thunder gives the distance of the storm in miles. The distance the storm is away from you in miles. Assuming that the flash of light arrives in essentially no time at all, estimate the speed of sound in meters per second from this rule. Okay. So first, we recognize that this is like some storm that's way far away, and there's some bolt of lightning that goes to the ground. What is lightning, you might say? That's a good question. Keep on us with physics here. We're going to be answering that question come second semester. Cool. But lightning right now is some mysterious thing that produces some light as well as a loud sound, which we call thunder. Okay, so we're like way far away here. And when I look at that thing, I can see that there's light coming there, and then there's like some sound that comes later. So light hits us first, and I don't know how to represent light hitting us first and sound hitting us second. So the light arrives in essentially no time at all, so we're making a slight approximation there, which for relatively small distances, and when we're comparing it to sound, makes sense because light, the speed of light, is a whole lot faster than sound, and we'll look at that more in depth as we go along here. So estimate the speed of sound in meters per second from this rule. Well, it says that it's for every 5 seconds that you count. Those look like the exact same thing. For every 5 seconds that you count, that gives us 1 mile. They give us like a ratio there. Now, miles per second is a weird thing, so I'm going to go ahead and I'm going to flip that fraction there, and I'm going to go every mile per time here, every 1 mile per time, per 5 seconds, is when you see something versus when you're actually hearing it there. All right, so now look at this, miles per second. Why did I do that? Well, I recognize that like things like speed and velocity, they're measured in usually some sort of like distance or displacement unit per some time unit there. And so I'm going to represent it in a similar fashion because notice we're trying to get it in meters per second in the first place. So 1 mile for every 5 seconds, or you could also say that that's just 0.2 miles per second. Now, it would be interesting to change that into, and the problem doesn't ask us to, but it would be interesting to change that into miles per hour. How many miles per hour is that? I'm going to go ahead and I'm going to do that over here just for fun. So I got 0.2 miles for every 1 second. And let's go change that into miles per hour. Well, I'm going to set up some proportions here of seconds per minute, and then I'm going to set up another proportion because those seconds are going to cancel out and we'll be in miles per minute. And so I'll need to set up another proportion here so that I can get rid of the minute unit, and maybe I'll get it into hours here. And now I can fill in some of these numbers, and you already know what these numbers are. There are 60 seconds in every 1 minute, and there are 60 minutes in every 1 hour. So now I'm just multiplying the numerators, dividing by all the multiples of all the denominators there, and 60 times 60 is 3,600. 3,600 times 0.2, 3,600 times 0.2, or divided by 5, gives us 720 miles per hour. And that's obviously going to be an approximation. When we go to see what the actual standard is, it actually depends on like the atmospheric conditions, how hot it is, what's the barometric pressure. But the standard at a standard temperature and pressure, which is 20 degrees Celsius, is 767 miles per hour. So far, yeah, we have a little bit of error there, but it's less than even 10% error. Maybe it's like a 5% error. So just eyeballing it there, you can go and find that error. So it's a pretty good one, we can see. But the problem asked for it in meters per second. So we're going to take our 0.2 miles per 1 second, and now we're going to change that into meters per second. Well, we're already in the per second, so I just need to get miles into meters. Well, do I know how many meters are in miles? No, I think I have to actually look that up. So meters in a mile. And so I go and I look it up either in a book, or in this case I just looked it up on the Googles. I go, hey, in 1 mile, there's 1,609.34 meters. And then when I do that, I see that the miles do cancel out there. That's nice. And now I go and multiply that together. Grab your calculator. Times 0.2. And we get 321.868 meters per second. And when we look at the standard is 343. Yes. I did have that memorized correctly. 343 meters per second. So again, a little bit off, but not even 10% off, and that's pretty nice for being able to just count in your head, figure out how far a storm is away. Sweet. So use that next time you're out in a storm. And I actually use this to see if the storm is getting closer to me or further away when I'm camping or backpacking. All right. Have a nice day. Bye.